All right, so in 8.2 we talked about the properties of parallelograms. So I'm actually going to scoot this guy over for a moment. Okay, and let's talk about what are the properties of parallelograms. So who can give me the, like by definition, what do you know about a parallelogram? Before that. Go ahead, Nick. Before that.
The parallel lines are equal.
Before that.
It's a quadrilateral.
It is a quadrilateral, and then what about it makes it special?
That it's parallel, double parallel.
The opposite sides are parallel. Good. So definition of a parallelogram is a quadrilateral where the opposite sides are parallel. Okay, that would be the definition. So opposite sides are parallel.
You know how squares are too, though?
Squares are parallelograms. So we're going to get into that. Yeah, that's coming up. Not today, but just you wait. All right, so then what else did we say? So some of you said opposite sides. What's true about what else is true about the opposite sides? They're parallel and they're congruent. Okay, and then opposite angles. Congruent. Consecutive angles. And what are we missing? Diagonals, good. Diagonals bisect each other. So I talked about this when I taught you these properties, but if you're one of those people that really benefits from rewriting things or having an outline, then I would definitely start keeping track of that, because these just pertain to parallelogram, and then eventually we get to be more specific into different kinds of quadrilaterals. Okay, so having known all that stuff, number 1 says to find the values of A and B. So A is one of the sides, right? The side opposite would be 30. So I can say that A minus 12 equals 30. And A would equal 42. And then B is in the angle. So opposite angles are congruent. So I can say B plus 10 equals 36. And B equals 26. Good so far? Raise your hand if you got them both right, both A and B. Good, okay. 2 says find the measure of angle K in the parallelogram. So I'm given that angle L is 64. What's the relationship between angle L and angle K? Supplementary. So 180 minus 64 tells me that angle K is 116 degrees. Questions on that one? Okay, now it says find the indicated measures in parallelogram ABCD. So again, it should either be marked that it's a parallelogram or state that it's a parallelogram. This time it says it in the directions. So angle BCD. So the only thing that you're given are angle B and angle D. So what else can I get from that? Nick. Look at the alternate interior angles. So this is parallel to this, and this is parallel to this, which means this angle here is 100. And this angle here is 37. And then BCD, which is here, would be supplementary to either of these angles, right? Either this whole angle or this whole angle. So if I did 180 minus 137, I get 43 degrees. And then 4 says that BE is 9, find BD. So this is based on your diagonals, right? We said that the diagonals bisect each other, which means BE would be equal to ED, which means ED is 9, and that would make BD what? Good. Questions on any of those? Okay. All right, so in 8.3, which is called showing that a quadrilateral is a parallelogram, we are now like taking the converse of 8.2. So in 8.2 we said this shape is a parallelogram, and if it's a parallelogram, then these 5 things are true. Opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, diagonals bisect each other, and consecutive angles are supplementary. Now we're flip-flopping it. We're saying, I'm going to give you information, and is this enough information to prove that the object is a parallelogram? So the first way that you can prove that a quadrilateral is a parallelogram is if both pairs of opposite sides are congruent. So if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. All right, second way to prove that a quadrilateral is a parallelogram is if both pairs of opposite angles are congruent. So in this example, if B is congruent to D and A is congruent to C, then this shape ABCD is a parallelogram. Okay, third way is if one pair of opposite sides are congruent and parallel. So it has to be the same pair of sides. In this case, if BC is parallel to AD and BC is congruent to AD, then ABCD is a parallelogram. So what's important about this one is it has to be the same pair of sides. Okay, so notice that the same pair of sides are marked as congruent and parallel. I can't have a parallel or a quadrilateral in which this side is marked as parallel and these sides are congruent. That is not enough information to show that that's a parallelogram. Okay, it has to be the same pair of sides. Okay, and then the next one is if the diagonals of a quadrilateral bisect each other, then the quadrilateral is parallelogram. So if this was an E in the middle here, if BE equaled ED and AE equals EC, then, well, I should put it in order, ABCD is a parallelogram. So both pairs, or both diagonals have to bisect each other. All right, so this one sums it all up. There's 5 ways to show that a quadrilateral is a parallelogram. Both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. One pair are both parallel and congruent. Both pairs of opposite angles are congruent, and then the diagonals bisect each other. So there's 5 ways, just like there's 5 properties of parallelograms, there's 5 ways to show that a quadrilateral is a parallelogram. And this is just like with the numbers of the theorems. So the definition is that both pairs of opposite sides are parallel. So if I was to use that in a proof, if it said, show that this was a parallelogram, then my reason would be the definition of a parallelogram. If it says show that both pairs of opposite sides are congruent, that's theorem 8.1. But remember, I don't want you to know numbers. I want you to know what this says. So for those, you're just going to have to write out, kind of like we did with the parallel lines. If both pairs of opposite sides are congruent, then it's parallelogram. Both pairs of opposite angles and one pair of opposite sides, congruent and parallel, and both diagonals bisect each other. So just get a little bit of a picture there. All right, so this kind of puts it all together in one example. So break it apart into 5 different questions. It says, state the principal definition or theorem that enables you to deduce from the given information that the quadrilateral is a parallelogram. So for number 1, it says BE is equal to ED and CE is equal to EA. So BE is equal to ED and CE is equal to EA. Is that one of the ways I know that that's a parallelogram?
Yeah.
Which one?
Shows the diagonals bisect.
Good. So I would just write if the diagonals bisect each other, if diagonals bisect each other. Then it's a parallelogram. And I'll let you kind of shorthand it like that, then just draw that little parallelogram symbol.
Can we just write the name in?
No, I don't want you to do the numbers, because the numbers mean absolutely nothing outside of this book. But that property is true in any geometry class and from here on out. But so number 2, angle BAD. So BAD is this angle, and DCB is here. And then angle ADC is congruent to angle CBA. Is that information enough to prove that this is a parallelogram?
Yes.
And what reason?
8.8.
Which is? Because if both pairs of opposite angles are congruent, then parallelogram. Okay, you do 3 through 5. All right, so 3 says that BC is parallel to AD and AB is parallel to DC. Is that enough information to prove that this is a parallelogram? Yes. Why? Alexis?
If both pairs of opposite angles are parallel.
Opposite sides, right? Yeah. If both pairs, opposite sides, then it's a then it's a parallelogram. So this is really the only one that has a shorter description because this is based on the definition. So I can actually say the definition of a parallelogram. That's the only one, okay, that applies to the definition. Definition says opposite sides are parallel. So I can use that in a proof or a one statement like this. I can just say that the reason for that would be the definition of a parallelogram. Okay, 4 is what? Both pairs of opposite sides are? Good. If both pairs opposite sides. Congruent, then it's a parallelogram. And then the last one, it's saying that these are parallel and congruent. Has to be the same pair. So if it wasn't the same pair, it would be not enough information to prove. So the same pair, opposite sides, congruent, and parallel. Then it's a parallelogram. So the proofs in this case can be as simple as that one step. Like if I gave you this statement as my given, you could write it as the given, and then the next thing could be that it is a parallelogram. And then let's say, I'm going to add one in here. So let's say A, B, C, D. Lovely little quadrilateral. So you're given AB is parallel to DC, and AB is congruent to DC. And you want to prove AD is congruent to BC. So if this is parallel to this and this is congruent to this, then what do I know about this shape? Logan. Good. So if this is given to me, then I can state that this shape, ABCD, is a parallelogram because if same pair, same pair, opposite sides, congruent and parallel, then it's a parallelogram. Okay, now what? Now if it's a parallelogram, do I know that the opposite sides are congruent? Yeah, so I can go straight to the prove AD is congruent to BC, because if it's a parallelogram, opposite sides are congruent. So if I can get it to the point, so they're going to give you enough information to get it to the point in which it's a parallelogram. And then if it's a parallelogram, that prove statement could be that the diagonals are bisected. It could be that the opposite angles are congruent. It could be that consecutive angles are supplementary. Okay? Any of that stuff can be true. Once I know it's a parallelogram. So they're not difficult proofs. Okay? But you do have to know your properties in order to figure that out. Okay? You got to know, one, is it not enough information to prove that the quadrilateral is a parallelogram? And then if it is, what can you figure out about it? All right?